So in our important series of problems, this is another important problem. The velocity of image we have to calculate. In the given situation, you see the object is moving with velocity 15 meter per second. That makes 53 degrees with principal axis. And the mirror, concave mirror, also moving with velocity 2 meter per second. And the focal length is given as 20 centimeters. And the object distance, say u, is 30 centimeter. So we have to calculate this problem. Let us see the concept first, and after that we can discuss the solution. So here, let us take this one is moving with the velocity Vm, and object is moving with velocity with Vo. So angle made is say theta, and the object is at a distance of u. The focal length of given lens is given mirror is say f. So here what we do is we resolve the thing into component, the velocity of the object into component. One is along principal axis and one is along vertical axis. Okay. So principal axis, let me take as x-axis, and vertical axis as y, perpendicular one. So the Vx becomes Vox, I write. Velocity of object along x-axis is, if it is velocity is v, okay, or v naught I took, no, here I wrote v naught. So v naught, v along x-axis the velocity is v naught cos theta. In the vector notation, if you write I cap. Similarly, along y direction, it is v naught sin theta j cap. So what is the vector? In the vector form, v naught can be written as v naught cos theta I cap plus v naught sin theta j cap. Right. Now, so what we calculate here is, the important formula is along x-axis, that is along principal axis, the velocity of image with respect to mirror in along x-axis, that is along principal axis, is equal to minus square of the magnification value m square into velocity of object with respect to mirror in x, in the principal axis direction, that is in x direction. This is the important formula, you remember. So here we can write as m square, velocity of object with respect in the direction of x is what? Vox, there we have written, minus with respect to mirror, so minus Vm in the x direction. If you want to remove x here, I cap you can write, that will write afterwards. Similarly, velocity of image with respect to mirror in y direction, that is perpendicular direction, is m into magnification into the velocity of object with respect to mirror in y direction, that is m into Voy minus Vm. If you want to write here Vmx also, you can write there in the previous case. This is Vmy. So this is another important point. And magnification. What is magnification formula? F divided by f minus u. That is focal length divided by focal length minus u, object distance. Okay, these are the basic concepts. Now we'll implement this to the problem. Then you can understand more clearly. So let us write vector image velocity of object Vo bar in the form of vector. This is V cos 53 plus V sin 53. And if you substitute the values, cos 53 and sin 53, you will get 9i plus 12j. Here you can pause the video, you solve the problem. And now next step, what we have to calculate? Let us calculate magnification here. Magnification is f by, that is 20 divided by, you have to apply sign convention. What is sign convention? In the direction of the light ray, all values measured are positive. In the opposite direction is negative. If you take positive x direction is the direction of wave incidence, or positive x you can take as the reference direction. All the values must be measured from the pole or center of the mirror. Then in the direction of the ray, or in the positive x direction, the measured values are positive, opposite to that negative. So focal length we measured in opposite direction. So minus 20 divided by f minus u, that is minus 20 minus u, that is object distance also we measure in opposite direction, minus of 30. So plus 30 it becomes. So value is minus 2. Magnification value is minus 2. So the first case, the velocity of image with respect to mirror in x direction is equal to how much? Vxi, that is 9i, minus velocity of the this one mirror, velocity of the mirror. It is in opposite direction, minus of 2 meter per second I. So you will get 11i. 11i into magnification. So here formula into m square, minus m square is there, no? Minus m square. Okay, so that you remember, minus m square into, that is the formula. So this is minus 4. Now we got minus 44i. Similarly, we'll calculate velocity of image with respect to mirror. See, the first thing we calculated along x-axis in perpendicular direction, that is in y direction, equal to formula m into velocity of object with respect to mirror. So minus 2, velocity of object in y direction is 12, minus 0, because in y direction there is no velocity j. So this is minus 24j. Let us write the complete vector. So what is the velocity of image with respect to mirror? Minus 44i minus, this is plus this thing, so minus 24j. So, but what they are asking is velocity of image they are asking. But we found velocity of image with respect to mirror. Velocity of image with respect to mirror we can write as Vi minus Vm, which we obtained as minus 44i minus 24j. So, therefore, what is the velocity of image? This is equal to minus 44i minus 24j. This, if you minus Vm bar, if you write this side, plus Vm bar. What is velocity of mirror? 2 centimeter, that is moving in opposite direction. So minus 2i. So if you calculate this, minus 44 minus 46i minus 24j, you will get, this is the required answer for us. Option B is the answer. Once go through the concept, and also I suggest you to solve similar problems using your whatever the material you are using.